Hi, I'm Mike North. I'm a senior staff engineer at LinkedIn and the company's TypeScript infrastructure lead. Going beyond the basics with this programming language can be really tough, but with my help shaping the way you think about types, you'll be able to understand, debug, and maintain even some really complicated types. In this course, we'll dig deep into mapped types, type queries, indexed access types, common JS modules, declaration merging, and more. By the end of the course, we'll have built up a collection of dictionary utilities that you can use in your own code base to map, filter, and reduce just like you love doing with arrays. I hope you enjoy the course. In this example, we have two what I'm going to call identifiers. And what I mean by an identifier is just a named thing that's defined in a single place. So we have one identifier called fruit, which is a type. We know that because it's an interface. And here is an identifier called banana, which is a value. TypeScript allows us to stack multiple things onto a single identifier. In this situation, we can see that we've named our interface and our const variable the same thing, right? They're both fruit, both with a capital letter. And we can see when we look at the tooltip for the interface, it's clearly just an interface. When we look at our variable, clearly it's just a const declaration. But look at what happens when we attempt to export this as if we were exposing it outside of this TypeScript module. We can see this tooltip contains both. There's our const declaration and there's our interface. These are actually two things stacking on top of the same word, fruit. There's actually a third thing that we can stack onto this tooltip, so to speak, onto this word, and that is a namespace. So in this example, we can create a class called fruit with a static, function on it. We can create a namespace, and you can think of this as serving a very similar purpose as static class, functions. And then finally, we have a type called fruit. So if we hover over this export and look at the tooltip, now we have three things: class, interface, and namespace. So this is three things in one. And now you may be wondering, when I'm importing stuff from other dependencies, how do I know what I'm working with? Well, I'm going to give you some investigative tools that you can use to probe around and to figure out what exactly is on one of these identifiers, right? If I'm given fruit, how can I test whether it's a class? How can I test whether it's a value or a type or both or maybe neither? So here are our tools. First, let's begin by creating a value, a type, and a namespace. And we've given them obvious names so that when I put them off the screen here, you can remember what's going on, right? So we've clearly got a value here. We've clearly got a type, which is just an empty interface. And then here we have a namespace. So you know something is a value if in a let or const declaration like this, you can put it on the right-hand side of the equal sign, and you get no error. If we try to do the same thing with the type, like we're doing down here, you can see that the compiler is not happy with us. And it's telling us, is a type only refers to a type, but we're trying to use it as a value. So this alerts us to the fact that this is purely a type. There is no value part to this identifier. Let's look at a similar test, but for types. So if we try to put this on the left-hand side of this assignment operator and we get no error, that's an indication that this identifier can be treated as a type. And look what happens down here. If we try to do the same thing with a value, we get an error message. The thing we're using, it refers to a value, but we're trying to use it as a type here. So that failure tells us there's no type piece to whatever is on this thing, which is purely a value. Now, there's no equivalent test for namespaces, although the tooltips make it fairly obvious what's going on. So you see the word namespace on the left of the tooltip. That is a clear indicator. So you'd have to hover over it in order to figure out what exactly is happening there. Extract and exclude. These utility types, which are included as part of TypeScript, they're used to obtain some subpart of a type, either through specifying what you're looking for or what you're not looking for. Extract is about defining what you're looking for and you get that piece. Exclude is about describing what you want to leave behind and you kind of get everything else. So these, behind the scenes, just use a conditional type. So we'll be able to put this concept we just learned into action now. So let's say we have a type that looks like this. So we have favorite colors, and we have a bunch of colors that are listed, right? So think of this, if we were in CSS and we were using the color or background color property, you can write out the word red, or you can define colors as like hash F00, or you could say RGB parentheses 255. You could specify your decimal values for each of those 8-bit color slots. So we're allowing all of that here. So we kind of have a mix, right? We have strings, we have a 3-part tuple, and then we have an object with properties red, green, and blue. So if we wanted to obtain only the subset of what's described by this type that is also a string, we could use extract in this way. And if we scroll to the right, you can see that we get just the strings. The tuple is not there. The object is not there. We could do the same thing by changing this second thing, the second type that we pass to extract. And now what we're saying is, give me things like within favorite colors. Give me whatever subpart of this type has a property called red, whose type is a number. We don't need to specify this whole thing here. Remember, it's not an exact match. This is a minimum requirement. So if let's pop this example out into the playground, and let's say, what if we did this? Let's add an alpha channel, right? We could, well, this is not going to be, because it overlaps so much with the other type. Let's say, I'm just going to do this. I just don't want one to be like strictly a superset of the other. I want them to have some overlap where we can see an interesting thing. So if we look at object colors now, look, we selected both of those, if you see in the tooltip. The object that has green and blue written as words versus their first letter. So it's almost like a query, like searching for things that might contain a substring of here's a fragment, go find me the whole thing. You can think of it kind of that way, at least when we're using it in this context. This is where we're doing the searching. Make that a little bigger. This is where we're doing the searching, and then this is the clue, right? This is the fragment to use as the basis for the search. That would be a perfectly valid way to think about this. And of course, with tuple colors, I'm just going to pop back here, we could search. So the result we get, of course, is number, number, number. Let's try some other things here. What if we just search for things like a tuple of length 1? We get a never, not found, right? That's what, in this case, it's like I examined everything, and here's the set I found, developer. It's an empty set. Sorry, But if we did this, what if it's a wider type, a more general type that still kind of matches what we're looking for? Hey, there we go. Yeah, an array of numbers that is exactly three slots. Sure, it is an array of numbers. It's a very special array of numbers, specific, but we can search for something that is more general. In the same way that up here, right, we're searching for any object that has a property red whose value is a number. And we were picking up more than one thing. So you search with something that's more general, and the matches will be at that level of specificity or even more specific, right? We're searching for any number arrays. And if we had, let's say we allowed an alpha channel here, maybe this one might work more interesting in a more interesting way. So now we'll get both. We'll get the 3-place tuple and the 4-place tuple. Why? They're both different kinds of number arrays. This is one of the key insights I want to make sure you walk away with, how to think of this specific versus general. What's this extends keyword all about? And this is really important in terms of making sense of what we're looking at here. Yeah, so in plain language, what this type is all about, we're extracting the subset of favorite colors that is assignable to string. That's specifically this thing up here, right? We're grabbing the subset that is assignable to a type. So let's imagine we have an interface called car. We can grab just the type of the color property here using, it kind of looks like the square bracket access notation for taking something off of a dictionary or accessing an element of an array. Note that although when working with values using these square brackets, we know that we can use dot notation, right? So if we have a dictionary and we saw this, we'd probably say, oh, well, why aren't you just doing like car.color? That will not work here. This must be using square brackets, and you have to pass a string literal type into it. So there is some enforcement of a constraint here. So color is present on key of car. But look what happens if we use something that's not on car. So you'll get an error message. There is some validation. This helps catch spelling errors, or if you were to remove something from car, you think it's unused, then have confidence that all of these indexed access types will light up. And of course, you can repeat this pattern, right? So if we only wanted to have the red part of car color, we could say, give me color, and then within that, just grab red. And so you could see these boxes, these square brackets, applied over and over. Interestingly, if we pass a union type through this indexed access type, we get a union type out. So year is a number, color is red, green, blue on an object. So you can see here, I call this projecting, right? You can almost sort of send your union type of keys into this indexed access type, and you get a union type of types of the values instead of types of the keys. Pretty straightforward concept. It's just sort of accessing a piece by name. And I know I use similar language to describe extract and exclude. Hopefully you can see the difference between what we're looking at here, which is grabbing a chunk of an object type as is, as opposed to like the conditional type with the infer keyword, where we were like grabbing the constructor, looking at the construct signature, plucking up the argument out of that. Like that's a much more heavy-handed way to do things. Behind the scenes, it's also much more expensive to do things that way. This is cheap. This will not really affect your performance.